Hi students, welcome to this new episode of Groundwater. In this episode, we are dealing with the transportation and depositional features of groundwater. Transportation by underground water take place in solution. So mainly the groundwater that is transported through the pore spaces are mainly undergoing solution action. Sometimes by solution action they are carried to the sea or lakes through percolation, and sometimes they are added to the stream water. Next come the deposition. The dissolved substances in solution are susceptible to precipitation and consequent deposition due to a number of factors. When the carbon dioxide and other dissolved gases are lost as a result of heating, evaporation or reaction, the solution capacity decreases. Hence, some amount of dissolved materials will be dropped from the solution. As a result of evaporation of groundwater, the solution will be concentrated with the dissolved materials, and thus the soluble matter may be precipitated. Decrease in temperature, pressure and chemical reaction also influences the deposition of substances in solution considerably. There are various depositional features produced by the action of groundwater. So, the depositional features includes speleotherms, it includes stalactite and stalagmite. Then comes dripstones, sinter and travertine, geoid, concretion, cankers and replacement. Coming to the speleotherms. Speleotherms are cave deposits. Speleotherms, commonly known as cave formation, are secondary mineral deposit formed in a cave. Speleotherms typically form in limestone or dolostone solution caves. It is sometimes referred to as a formation or decorations or cave features formed by the deposition of minerals. The word speleotherm is derived from the Greek word speleon meaning cave and thema meaning deposits. So, regarding the speleotherms, one of the speleotherms discussed here is stalactite. So, these are calcium carbonate deposits of pendant like masses hanging down from the ceiling of a cave. When a percolating solution comes to the roof of the cave in limestone region, mainly above the water table, these features are seen. Here, due to the solution, it may be seen dropping through the fractures in the roof of the cave. So, in the caves there are so many fractures associated. So, along with this fracture zone, the solutions are seen to be dropping through the fracture. When the solution lost some amount of water and carbon dioxide by evaporation, the calcium carbonate will be deposited at the point of the evaporated drop. So, by similar continued process, further deposits of calcium carbonate will take place and ultimately form a pendant like masses hanging from the roof of the cave. So, above the roof from the fracture zone, these type of calcium carbonate deposits starts growing towards the floor. So, they are tapering and grows towards the floor. So, these are cave deposits which are mainly seen from the roof of the cave towards the floor. So, it is an icicle shaped formations that hangs from the ceiling of a cave, and it is produced by the precipitation of minerals from water dripping through the cave ceiling. So, most of the stalactites have pointed tips. So, these are nothing but calcium carbonate deposits from the water. So, these calcium carbonate deposits are precipitated from the roof pointing towards the floor. So, this type of cave formation can be called as stalactites. So, in this picture you can see the stalactite growing from the roof of the cave pointing towards the center. So, this is the picture of the stalactite, and here this is mainly made up of calcium carbonate formed from the groundwater. So, the remaining part of the minerals are precipitated and only thing back is calcium carbonate. So, this is deposited from the roof towards the floor. So, this type of deposit is a stalactite. So, this is another picture. Actually, this is a cave. So, from the roof of the cave, this calcium carbonate seems to be hanging like pendant towards the floor. These are also same thing. You can see some deposits coming from the floor region. So, that is another thing, another type of cave formation. So, the pendant like things hanging from the roof of the cave is the speleotherms. Next type of cave formation is stalagmites. These are also calcium carbonate deposits which grow upward from the floor of the cave. So, normally stalactites grow from the roof to the floor. So, these stalagmites are also calcium carbonate deposit which grows upward from the floor of the cave. Some amount of solution will fall on the floor of the cave, and upon it a dome shaped or conical deposits of calcium carbonate start growing upwards as a result of continued evaporation. So, there is some chance of falling some amount of solution on the floor. So, as the solution falls on the floor, it started growing upward as a result of continued evaporation. So, these deposits which are found on the floor and pointing upwards are known as stalagmites. So, a stalagmite appears like an inverted stalactite rising from the floor of a cavern. So, instead of stalactite, a stalagmite appears like an inverted stalactite, that means it rising from the floor of a cavern. So, this is the picture of a stalagmite. In this you can see the calcium carbonate, it is formed of calcium carbonate deposit, and it is seen inside the cave. It start growing from the floor towards the roof of the cave. This is also a cross section of a cave complete with stalactites and stalagmites. You can see so many stalactites and stalagmites growing from the roof and from the floor. This is also another picture. So, the entire thing is a cave and water is stored within this cave. Due to the depositional action of the groundwater, these type of calcium carbonate deposits are precipitated from the groundwater, and it appears to be like depositional hangings from the roof of the cave and also from depositional things from the floor of the cave. This type of stalactite and stalagmites can be very clearly seen in vellum caves. Next is dripstone. Dripstone is nothing but the combination form produced by the combination of stalactite and a stalagmite. So, here rock deposited by precipitation from dripping water such as that which form stalactite and stalagmites. So, it is a type of speleotherm. So, dripstone is also another form of speleotherm or a cave formation. With the increasing growth of the stalactites and stalagmites, they may be joined together and a columnar deposit will be formed. So, this type of columnar deposit formed by the joining of a stalactite and a stalagmite is known as a dripstone. So, you know stalactite is growing from the roof of the floor, stalagmite from the floor of the cave. So, these two speleotherms join together to form another type of cave deposit, and that type of cave deposit is known as dripstone. So, dripstone is also calcium carbonate in composition. So, this is a cave. You can see the stalactite and stalagmites joined together forming dripstone. So, these are also another speleotherms mainly made up of stalactite and stalagmite. Next type of groundwater deposit is sinters. Sinters are siliceous deposit. The silica deposits formed at or near the exit of springs are known as siliceous sinters. That is mainly made up of siliceous things. So, it is known as siliceous sinters. So, sinter is a whitish porous incrustation usually consisting of silica that is deposited from hot springs, and this is a product of sintering process. So, hot springs, you know, it is the spring just like discharging hot water. So, this hot water is mainly due to the magmatic action. So, somewhere near the earth's interior magmatism is going on. So, due to this magmatic impact, springs discharge hot water. So, this type of siliceous deposits are seen deposited along the hot springs region. So, this type of siliceous deposit seen along the springs are termed as sinters. So, this is a sinter mainly seen at the region of hot springs or normal springs. So, it is the exit of the spring. So, you can see the groundwater deposits, this white concretions seen at this exit of the spring is the sinter deposit. So, it is nothing but silica deposits mainly deposited from the groundwater. Next is travertine. Travertine is a form of massive calcium carbonate resulting from deposition by springs or rivers. So, just like siliceous sinters, this travertine is a form of massive calcium carbonate resulting from the deposition by springs or rivers. So, by the deposition of the springs or rivers, calcium carbonate is also precipitated just like sinters. So, this type of calcium carbonate deposit formed by the deposition of springs are known as travertine. This material is variously known as calc sinter. So, since it is mainly made up of calcium carbonate, it is also known as calc sinters. So, the picture is seen depicted here. You can see the white color thing. So, the deposit is mainly made up of calcium carbonate and it is known as travertine. Another depositional feature is geoid. It is a structure formed by the depositional activity of groundwater. So, just like travertine, sinters and all, this is also another structure formed by the depositional action of groundwater. It is a cavity in rocks lined with well developed crystals of quartz projecting towards the center. So, there are so many cavities present in the rock. So, these cavities are mainly produced by the erosional action. So, these cavities are lined with well developed crystals of quartz projecting towards the center. So, by the solution action, this groundwater is slowly transporting through the rock pores. So, from the caves or from the rocks interior, it is lined with well developed crystals of quartz. So, quartz is nothing but silica. The silica starts crystallizing from the cavity within the rocks and these quartz crystals are seen projecting towards the center. Below the water table, inside the smaller cavities of rocks, layers of amorphous silica are gradually deposited. So, inside the cavities, the amorphous silica are deposited layer by layer. Successive deposited layers of amorphous silica may vary in their color and texture. So, it is formed by successive deposition. So, the color is not similar, it may vary in their color and texture and the deposits are known as agate. So, it is a type of geoid in which the successive deposited layers of amorphous silica vary in color and texture. So, that type of geoid you can call as agate. If the deposition is perfect, the well developed crystals of quartz are seen projecting towards the center of the cavity and these deposits are known as geoid. From this picture you can clearly make out the difference. So, here this is a geoid. In this picture you can see quartz crystal pointing towards the center. So, this is another type. Here the amorphous silica is deposited layer by layer. So, this type of deposit is called as agate. So, this is agate. Here it is mainly made up of amorphous silica and it is separated layer by layer. Both of this can be either geoid or agate. So, this is agate and this is geoid. Both are depositional features formed by the groundwater action. This is also geode. Here you can clearly make out well developed crystals of quartz pointing towards the center. So, actually this is a cavity within the rock. So, this cavity is formed mainly by the erosional action. By erosion, the entire rock is soluble and the cavity is formed. So, from the cavity, by the depositional action of groundwater, quartz crystals grow from the pointed from the cavities towards the center. So, this type of projecting crystals of quartz are known as geode. So, it is a depositional feature produced by the groundwater. Next depositional feature is concretions. The development of spherical, nodular or discoid forms which are formed on rocks by the deposition action of groundwater are called concretions. So, concretions are spherical or nodular or discoidal forms which are formed on rocks by the depositional action. So, by the gradual deposition action of groundwater, the development of nodular or discoidal form is produced. So, these type of structures are known as concretions. Concretions consist of round or irregular masses of more resistant rock formed as a result of cement precipitating around a core material, usually a fossil or a grain of a different composition. So, actually the concretion consists of a nucleus. So, that nucleus or core may be any cementing material, or it may be a fossil, or it may be a small grain. So, around this grain, slowly from the water, disc shaped or nodular shaped structures are formed. So, this type of structures formed or precipitating around a core material is known as concretions. It is a hard, compact mass of matter formed by the precipitation of mineral cement within the space between particles, and it is normally seen in sedimentary rock or soil. They are often ovoid or spherical in shape, although irregular shape also occur. The word concretion is derived from a Latin word. Concretion means together. So, this is a typical picture of a concretion. Here you can see nodular like structure. So, inside the nodular structure there is a nucleus. The nucleus is either a small bit of sand grain or a small bit of fossil or a rock piece, whatever it is. Over that nucleus some materials are precipitated and it forms like nodular or ring like form. So, these type of deposits formed from the groundwater is known as concretions. The next depositional feature is cankers. So, just like nodules and all, this is another type of depositional feature produced by the action of groundwater. These are loose gravels and alluvium which have been subjected to cementation, forming compact masses known as cankers. So, loose gravels and alluvium that are carried by the groundwater are subjected to cementation. So, this loose gravel and alluvium subjected to cementation forming a compact mass. So, this compact mass of loose gravel and alluvium is known as canker. So, this is also formed by the depositional action of groundwater. So, groundwater when it is transporting along with the pore spaces, when the transportation is less, what will happen? Precipitation will take place, and from the water this type of gravel and alluvium becomes compact, and these compact masses are known as cankers. And the last type of groundwater depositional feature is replacement. So, replacement, as the term is well known to you. Replace means you are replacing something with another material. So, here groundwater containing carbon dioxide dissolves the material exist in any significant substance and at the same time deposit an equal volume of material. So, here the materials exist in any significant substance, at the same time it is deposited in equal volume of material. Such substitution commonly occur molecule by molecule, so that original structure of the dissolved substance is kept intact. So, here the replacement is taking place molecule by molecule. So, original structure of the dissolved substance is kept intact. There is no change for the original structure. The replacement is taking place molecule by molecule. So, tree trunks are sometimes changed into solid hard masses, which are called petrified wood. So, petrified wood is nothing but tree trunks converted into form of rock. So, tree trunks sometimes changed into a solid hard mass. So, that is petrified wood. So, petrified wood is a very good example for these type of replacement reaction. So, replacement, by the replacement reaction, groundwater performs depositional character, and due to the replacement reaction performed by the groundwater, petrified wood is formed. Such petrification involves the solution of woody tissues and equal deposition of siliceous material. So, the wood is replaced by silica material. So, actually the woody tissues are replaced and an equal volume of equal deposition of siliceous material are deposited instead of the wood tissues. So, this type of structure formed mainly by the replacement action is known as replacement reaction, and the product formed by this replacement mechanism is known as the petrified wood. Petrified wood is wood changes it into a rock by the replacement process involved within the groundwater depositional feature. Now, let us memorize what we discussed in this episode, mainly regarding the depositional features produced by the groundwater. The depositional features discussed here are mainly the speleotherms. Speleotherms include stalactite and stalagmite, next dripstones, sinters and travertine, geoid, concretions, cankers, replacement. So, regarding speleotherms, they are cave deposits mainly formed of calcium carbonate. So, stalactite is a type of groundwater deposit formed from the roof of the cave tapering towards the floor of the cave. Stalagmite, it is also another calcium carbonate deposit that is formed from the floor pointing towards the roof. Now, the dripstones, the combination of a stalactite and a stalagmite is known as a dripstone. So, dripstone is a columnar deposit formed by the combination of stalactite and stalagmite. Sinters and travertine, these are also siliceous deposits formed by the deposition action of the groundwater. Then geoid, geoid is a groundwater deposit mainly formed within the cavities. So, from the cavities silica starts to crystallize and the silica pointing towards the center of the cave. And coming to the concretions. So, concretions are also siliceous deposit mainly formed around a nucleus, and this nucleus may be either a sand grain or a part of a fossil or a piece of rock. So, around this piece of rock or around this nucleus, slowly from the groundwater minerals are deposited, and this type of deposits is known as concretions. Cankers are also similar type of depositional feature mainly produced by boulders and all. So, along with the boulders, the deposited materials are seen coagulated around the material. So, the last type of groundwater deposit is the replacement type of deposition. So, here the replacement type of deposition feature, the entire thing is replaced by another material. So, the best example depicted here is the petrified wood. In the case of a petrified wood, the wood tissues are slowly replaced by the rock materials. So, that is the best example, petrified wood. With this, we have come to the end of this episode. I hope you have understood all the features discussed in this session. In the next episode, we will discuss about the water quality. Till then, bye.